I would like to introduce James Broyan, who will be giving us a talk on lunar life support overview. Welcome, James.
Okay, great. Can you hear me okay now?
Yes, we can hear you just fine.
Great, thanks. Next chart. So I'm just a NASA Environmental Control and Life Support Systems Crew Health and Performance System Capability Leadership Team. I got a lot of charts here, so we'll try to work through them all quick. But just the next chart, I'll talk a little bit about crew health and performance. We have 9 capability areas: life support, environmental monitoring, fire safety, logistics, EVA physiology, not the spacesuit, countermeasures, radiation protection, exploration medical, and food and nutrition. And we have some key parameters that drive our different technologies, even though in general we're trying to provide the same resources to the astronaut. Next chart. So our considerations, what drives our life support for lunar habitats is just the reliability. As most folks realize, it's very difficult to get to the surface, and our ability to resupply is very limited. And so reliability and testing our components significantly and for long periods of time beforehand is very important. And although individual initial missions might be short, and some of the elements might be small, but when we make technology decisions, we look at sort of the integrated perspective, and that really helps reduce the time frame for when life support closure makes sense. Next chart. Okay. And are we presenting in both teams, breakout session and this at the same time? Okay. Well, sustainable exploration, I think Julie Robinson and others have explained how space station and gateway are going to inform some of our lunar missions. Next chart. And so one of the more significant differences from what we're doing today is looking to move resources between different elements. And so we have do recycling in the foundational surface hab element or a permanent habitat element. But even if we get resources from ISRU in the future, we're going to want to recycle those because we spent a lot of energy recycling or painting those resources. We want to clean them up. The degree of loop closure we might do might change, but it's still very important. And so looking that we would transfer various oxygen to rovers and spacesuits. We might collect wastewater and urine from rovers and bring it back. Let's see here. Let's see. Let's see here. And next chart. Potential science interactions. So we have several areas I'll talk about. If science was looking to use potable water, we use biocides, silver and iodine. So do those need to be removed before you might be able to use that? Do those interact with your science? We're looking at generating disinfections, hydrogen peroxide. Is that useful to you in cleanup before you do your experiments? If so, understanding what you need, concentrations and quantities would be very useful. Lower atmospheric pressure, as people have mentioned, using 8 and 10 psia to facilitate frequent EVAs. And I think Morgan Abney had mentioned some of the thermal considerations. But additionally, if you have a process in your science that uses diffusion, your diffusion process and timescales may be different, something to consider. It certainly impacts some of our CO2 removal technologies and trace contaminant control technologies. Reduced eclipse is planned during dormant periods. And so if you're planning to do science,
I've been trying to unmute you and I can't do it.
okay. So So what science atmospheric conditions, are required with there's no crew, defining those so that those can be planned in. We're looking at possibly reducing the temperature and humidity levels in the habitat to around 50 Fahrenheit or 40 Fahrenheit. So if you have requirements for that, it would be very important to understand. And next chart, please. And the habitats, we vent purposely some of our CO2 trace contaminant removal systems. The spacesuit vents purposely, primarily water vapor, but we also leak other contaminants. And so any condensable gases we're leaking out, which is at the temperature ranges on the moon, can include a lot of items. Those likely will eventually deposit on colder surfaces and maybe in the permanently shadowed regions. And so you need to think about whether samples are taken with EVA, or how close they are to the habitat. What do you need to do to understand the contamination? And then there's certain byproducts that come out of ECLIS. And in the backup charts, which I won't be able to cover, it does have a breakout of some of the things that we believe or estimate will leak out from a habitat. Trash disposal from the habitat, when it goes outside, that'll off-gas. We can reduce the amount of off-gassing of water vapor and other compounds depending on the amount of processing we may do. That's just an example on the right there of Apollo, where they have a sort of a dedicated disposal zone. And so how close is that going to be to places of scientific interest? Monitoring capabilities, looking at radiation sensors, trace gas analysis, water constituents, microbial, and even some ultrasound technologies. Are those maybe useful to different science experiments? If we know that up front, we could design interfaces to accommodate external samples so you don't have to maybe provide all that instrumentation on your existing science platforms. And then dust filtration, there's been a lot of talk about that. Right now it's targeting based upon respiratory limits, but if you need a cleaner environment, then we would need to understand that so we could adjust the vehicle levels. Next chart. And then just in summary, life support is, really driven by reliability. And so we're trying to leverage the ISS technology to ensure reliability, and includes, restart after a long period of dormancy. ECLIS venting and surface trash will, locally contribute to signatures, for science being conducted outside. So we need to identify, are there particular compounds of concern for science so that we can quantify what our release rates are, or potentially try to mitigate or reduce what we might be, venting or leaking from the habitat. Understanding trash disposal, and then understanding, influences on the habitat or from the habitat to science. It may be possible to share resources like monitors, and then we need to identify, what products and environments might be needed. If you're going to use potable water during the dormant period, we need to make sure that's available to you or stored beforehand so it's available to you. And that completes the slides I have.
Great. Thanks, James.